Hello, I'm Devitt here at New Way Gas Bearings, and we'd like to show you how we're integrating our gas bearing technology into seals or seal technology. In fact, even the ventless seal that you'll see here. So what we have are two bearing pedestals, and there's two bushings that are supporting a large shaft. So as I spin it, you may be able to see that shaft spinning. It's completely frictionless. It's not touching anything. It's a 4 1/4 inch diameter shaft through these two bearing pedestals. Now here we have the seal body itself. You can see this is a thrust flange here. There's another thrust flange back here. And we have a double opposed seal on the inside here running against these two thrust faces. And if you come around and have a look on this side, you'll see that the seal body is got a torque arm here, and the whole body is also supported on radial air bearings. And so these radial air bearings allow it to translate back and forth a little axially and radially. This allows us, when we put this torque arm on a force gauge, to measure the exact shear from the air film in the seal that's being transmitted. So that's a direct relationship to heat generation in a seal body. So we think we can keep almost all the heat generation completely out, and we're going to be able to prove it with this force gauge. So the torque arm allows us to measure the torque or the drag of the seal, but the most important thing is that we can segregate the gases. By adjusting the input pressures independently of each other, we can steer the high pressure point back and forth across the land. Using a gas detector, we can determine the exact balance point where all of the process gas goes back into the process, but none of the buffer gas will flow into the process. All of the buffer gas will flow back to atmosphere, but none of the process gas will go to atmosphere, essentially segregating the gases in a single seal face. Thanks for listening to this quick description of our ventless seal technology.